How do we graph inequalities? That is the topic of today's video. If we look at this number line and we wanted to graph x equals 3, for example, how could we do it? So x equals 3 is an equation, and equations usually have just one right answer, one solution. So x equals 3, we could graph this by going to 3 and drawing a closed circle. Okay, actually let me change the color a little darker there. So here we go. If we have a dot at x equals 3, that's our graph. One solution. But what if instead of x equals 3, we have x is greater than 3? How could we graph this inequality? We would still go to 3 right here. We would still draw a circle, but this time, since we have greater than, it's like an arrow pointing to the right, we are going to draw a line with an arrow pointing right. Okay, so right here, greater than points to the right, so we're going to draw a line pointing to the right. This right here, a circle with an arrow pointing right at 3, this is the graph for this inequality. All right, let's do several more examples of these. How about x is greater than or equal to, and let's say -7. How do we graph this inequality? All right, well, we would go to -7, which is right here. We would draw a circle again, and it's greater than, right? So we're still going to the right. Still, oops, that's messy. Still going to the right. But this time, since it's greater than or equal to, this or equal to, we will fill in the circle. This is the graph of x is greater than or equal to -7, this right here. Okay? What about x is less than 9? X is less than 9. Okay. So perhaps at this point, you can guess, we go to 9, we draw a circle, and since it's less than going to the left, we will go to the left, like this. Boom, x is less than 9. All right, and how about x is less than or equal to, let's say 0? How do we graph this? Well, let's go to 0. Note less than or equal to, so we will fill in the circle, fill it in. And then less than or equal to, pointing to the left. Okay, so that's it. That's pretty much it in terms of graphing simple inequalities. Now in high school, you can get into complex inequalities, but if all you see is a variable is greater than, less than, greater than or equal to, less than or equal to something, it's very easy to graph. That's it. Okay, so x is greater than a number. You would draw an open circle to the right. X is less than a number. You would draw an open circle to the left. If x is greater than or equal to something, that would be a closed circle to the right. And if x is less than or equal to something, that would be a closed circle to the left. Okay, so just keep in mind that an equation would be x equals something specific. That would just be one dot at wherever the number is. One solution for many equations. But for an inequality, if you have like x is less than something, remember we need to draw the arrow because an inequality generally has infinite solutions, right? Like x is less than 5. That would mean, oh, wrong, 5. For example, x is less than 5. We would go to 5, open circle, and this arrow pointing to the left means x can be anything that's to the left, anything less than 5, right? That's what this arrow means, infinitely many solutions. So in an inequality, when you're graphing, the dot, the circle that you draw, it serves as the boundary point. Okay? That's the boundary point. So it serves as the boundary, that's the limit. And when you fill it in, that's when it's or equal to. If it's just less than, open dot, like that, okay? So let's look at a few word problems and then we'll wrap up there. So what if we have, let's see, what if we have this situation here? A flight needs outside temperature warmer than -5 degrees. A flight needs outside temperature warmer than -5 degrees. How could we represent this on a graph? Okay, so here's our number line. So, warmer than, for temperature, warmer temperatures means higher. Okay, so warmer than is going to be greater than. So if we say temperature, outside temperature, or flight F, so I'm saying T needs to be warmer than, greater than, -5 degrees, -5. T is greater than -5. So if this is our number line, this is 0, this is -5. To graph greater than -5, it would be an open circle going to the right. Okay, an open circle going to the right. What about a digital scale is accurate up to 5 grams? How can we represent this as an inequality? A digital scale is accurate up to 5 grams. Okay, if we look at up to, so up to, that sounds like it includes 5 grams, right? As long as it is up to 5 grams, it's safe. So this would be a less than or equal to. Up to 5 grams. So we can say a digital scale, maybe S for scale. Actually, S looks like 5, so D. The digital scale is accurate up to 5 grams. D is less than or equal to 5. So let's graph this. Number line 0. Okay, this time 5 would be right here. And if we're looking at less than or equal to, that's going to be a closed circle pointing to the left.